All right, you ready for, do we have time for another one? We have a lot of time, Everybody good? All right, so longest common subsequence is another classic example. You do computer science anywhere in the world, I bet you they'll cover this. All right. The input, 2 strings. A solution is a common subsequence. So ABC, you'll note ABC is a subsequence of X. And what do we mean by subsequence? A sequence is letters in a particular order, right? And you can repeat letters. And then a subsequence is a subset of those that still can repeat letters, right? And so you can see ABC is a subsequence. And I made, I made my letters so that you could find them easier. ABC, I don't know. And it's a subsequence of Y, right? That's a solution. The cost of the solution is the number of letters that you've managed to grab. And our goal is to find from the title longest common subsequence. Right? Everybody good with the problem? I stole this from James Elder, who's a professor here. So here, if you have Springtime and Pioneer, you can see a longest common. Everybody see the lines of the longest common subsequence, right? Now we're going. So the way I would have done it before is I would say, okay, I have my instance. What do I ask the bird? It's kind of complicated what we ask the bird, and I have many slides sort of thinking about what do we ask the bird, and can we ask the bird less things, and it really we spend a half an hour doing this, and I think, though I don't remember because I haven't looked at it since I did it a year ago. I think that when we do it to the graph, it's really pretty obvious and fast, right? Which helped me motivate doing this switch. All right, so what's our story, right? We definitely are moving forward through these, right? And we move forward through them at different rates, right? So you need an index I and J, and come on, Pooh Bear needs to know I and J, right? That's for sure, right? And he moves through them, right? Here we are moving through them. So what do we tell him? He definitely needs to know I and J, right? Everybody agree? And in some ways, he doesn't need to know anything else. Right? If he's on this I and J, he's now trying to go forward, matching letters, and he doesn't care what happened in the past, right? So bang, we can fill in our table, right? We made this table without worrying about birds yet, right? So maybe this is easier. So, right, so here, and I wrote along here the input, right? So let's see, if I'm Pooh Bear and I'm standing there, then what am I trying to do? Oh, that doesn't look right. I would say that it would go over to G, we go over to T, right? I think that's a typo, right? But I'm making these slides last year, bang, bang, bang. So what is this subinstance? Well, I got the input through G and the input through T, and I'm trying to find the longest common subsequence, right? Everybody buy that? All right, so imagine that we're actually on, right? Oh, or maybe, I don't know. Anyway, this is what the slides are. All right, so now we're looking at our last letter, right? This is not it's the letter we're sitting on, right? So we're sitting right here, we're sitting on this T and this G, and we're looking at them. And can we match them together? No, you can't match them together. So what do? You move past them, right? Do we move past both of them? No, because one of them might get matched to something else, right? But here's can both of them get mapped to something else? Yeah, I think the argument is, if you think about it, both of them can't be mapped to something else, right? So, yeah, exactly. So here, right, they're different, so we reject at least one of them, right? And which one do we reject? How do we decide which one to reject next? How? Yeah, so how do we choose right now? The bird tells us. The non-deterministic gift from the goddess comes down, tweets in our ear, which one to go past now, right? Bird, there it is. If the bird says, move past xi, then right, then that letter's gone. We're not going to use it, and we move down. Right? Does that make sense? And when we move, we're moving. That's an edge from here to here. Right? Right. So here I'm in state ij, ready for the ith and the jth node. Right? I move up to I plus 1 because I'm ready for the I plus first letter of x. Right? And right, so we made that a little longer. And what weight do we want to give this edge? Is, well, we had a path to our previous node, and then we have a path to the next node. And so actually, and funny here, when I was making slides, when I was, I read over the slides I made, the way I had made them is the weight of an edge is the length of this path minus the length of this path, kind of a derivative, right? The difference. And I thought that it was all too confusing back then. So I deleted those slides and just made it, hey, what's the weight cost of this action? But now we're back to, well, what's the action? Well, does it cost any more to get here than to get here? What's our cost? Remember, our cost is the number of it's not even a cost, it's not a bad thing. We want to maximize the number of letters we've taken. And if we've taken any more letters, no, right? So nothing, we got nothing here, guys, right? Does that make sense? All right, so now we're going back. We're back here. So those still aren't the same. These are copied slides. We just changed it to the bird tells us why. And now that one's gone, and we go forward there with the cost of 0, right? Does that make sense? Let's remember what our job is, right? You don't want to panic by worrying about everybody's job. You want to worry about your job. Your job is given the input X and Y to make a graph. You are not doing it. You are not traversing this graph. You're not finding the path. Our oracle is going to find the shortest path, right? Our job is only to make a graph, right? And I like to be able to tell a story. So the story is my bird tells me which edge to take if I was walking. But the truth is, we're going to take this graph and we're going to give it off to some subcontract to who's going to find us our path. Yeah. Yeah, right. So if you're right, you're either going to take this action or this action. If you happen to be sitting here, and you might not actually ever sit here. If you happen to be sitting here, you'll take this action or this action, right? Right, so now we're sitting here, right? And why is this extremely fun? Is because here's our solution so far, happens to be AB and AB matched. We're now looking at two letters that are the same, right? So what do? You could say, well, we could skip one, but why? They're at in some ways, they're the beginning of your sentence, your string, right? boy, if your letters start with the same letter, dude, match them, right? So here they're equal. We're going to put both of them into our longest common subsequence. If you didn't catch what that those letters were. And so we move forward on both, right? Now, what's the weight of this edge? 1, right? Because we got one more letter, right? Everybody see it? The value of this action was 1. We got one more letter, right? Boy, that was easy, right? How hard was that, guys? Right? I mean, we kind of have bird answers and questions, right? Bird answers are in there. We did ask the bird, do we take this next letter or do we not take this next letter, right? There's a bird in there and there's friends in here, right? So the bird's friend algorithm is still sort of here. The difference is the way I do the bird's friend algorithm is I'm standing at the end and I'm asking, what are the last edges, right? Do I take the last letter of X? Do I take the last letter of Y? Versus here, I'm here and I'm saying, what do I take next, right? So it's a bird friend algorithm. It's all in here. Everybody got this? So we do a reduction, right? We have, maybe we outsource this out of the country, right? We're given our letters, we form our graph, we send it out, comes back, we get a path, which we get our answer for, right? Everybody buy that? So easy. Number of states is, we have N letters in X, M letters in Y, so that's the area of our matrix. How many bird answers are there? 2, right? Because in some nodes there was this and this, and in some nodes there was only 1. So what we're gonna, who cares about that, right? So we just call it 2, and that's our algorithm. It's running time, right? Everybody good? See how, man, that was so much faster than I've done it before, right? People kind of buy that. And so chances are on the code, what am I going to give you on the test? Maybe I'll make you, I'll give you a new problem and you'll have to forward this graph. But maybe for fun, I will also make you give the code, right? And so it's basically you write the code for shortest path, longest path, and you change it appropriately. And if you're looking for how to study doing that, then I changed the web page yesterday. Remember, it used to have old greedy and new greedy. Old greedy went to an old dynamic went to a page by itself, and so you go to the original page and you look for a link that says go to the old stuff, right? So you go over to the old stuff and you look for the old slides and you look for longest common subsequence, and you'll see how we did it then, and you can read the code and see if it's do it yourself first, right? Everybody kind of buy that? And it's easy, so easy, right? If you understood what we're doing so far, there's just no changes, right? Everybody good? Now how are we doing for time? Man, we did that one fast, didn't we? We are just flying along. So